All right, so we'll get started, guys, as soon as 6 o'clock comes around, but it's about 6 o'clock. All right, so it is 6 o'clock already. So let's see. Only got a couple of us here right now. We got Juan. Now we got somebody else coming in too. Let's see who else is here. Lauren is joining in too. Let me stop sharing this real quick, y'all. I'm going to let Lauren join in, and then we'll go ahead and get started. Let's see. So as Lauren is joining in, Antonio and Juan, you guys are the ones that are here. Lauren is here as well. So we got a couple of options, y'all. I'm going to give you guys two options as well. So I'm going to say choice A is answer homework questions, and choice B is cover 4.2 rules of exponents and 4.3. So that's supposed to be a B. Hello, Lauren. So the cover 4.2 rules of exponents, 4.3, that was supposed to be choice B, y'all. So Lauren, Antonio, Juan, what do you guys, Juan, what do you prefer since you're here with me today in person? Do you have any homework questions that you have for me that you want me to go over? From 4, you have some from 4.3? Okay. Lauren, Antonio, do y'all have any homework questions you want me to go over? From 4.2, okay. Antonio, anything yet? And Lauren, I'm not sure if you're asking me to cover 4.2 or if you have questions from 4.2. So do you want me to cover 4.2 or do you have questions from 4.2? Okay, you have some questions? Okay, so Lauren, why don't you get your questions ready? And Juan, do you know which question it was from 4.3? Oh, for me to cover 4.3. Okay. So, so I can definitely do that. Lauren, as you're getting your questions together, Antonio, do you have any preferences? I can definitely cover 4.3 today, y'all. But Antonio, I don't know if you have any preferences of what you need from me today. Okay. So I'll tell you what, why don't we do it this way? Hello. Why don't we cover 4.3, you guys? And I'll cover 4.3, and then those of you who have questions, we can go over those, okay? So let me share my screen with you guys again so you can see what it is. Oops. Yeah, what it is I'm looking at here. Okay, so that was 4.2. And let me pull up 4.3. So, y'all, there was another section that y'all had to do. It was just rules of exponents. And I want to say there was maybe 2 or 3 problems, but they had like, parts A, B, C, D, E, all the way to Q or something like that. There was quite a few questions there. So what I kind of want to do before I go into 4.3, I just want to do a handful of these problems here. Just so that we kind of understand the idea behind these rules of exponents. So let me I'll do a couple of them from this part here, and then I want to say there's another problem over here. Yeah, and I think there's just a little bit of problems here. So let me do just a couple of, maybe 2 from each part, just so we have a general idea of what rules of exponents are, okay? All right, so in dealing with these rules of exponents, you guys, let me get my pen going. We're going to evaluate what we call a to the power 1 over n. So I want you to notice that my power, y'all, is a fraction. So like if I were to ask you, say, what is 2 to the 3rd power? You know that means 2 times 2 times 2, which is going to give us 8, right? But now we're looking at powers that have like fractions as their powers. So when I see something like 36 to the power 1/2, what this means, y'all, this means I'm taking the square root of 36. With square roots, we normally don't put that little number there, but I'm putting the number there because I want y'all to understand it's the square root, okay? So if we would say, okay, what's the square root of 36? Oh, we would say that's just the number 6, right? That's what it happens to be, okay? And then let me pick another problem like, say, oh, I don't know, let's pick G. And it's negative 27 in parentheses to the power 1/3. So when I see something like this, negative 27 to the power 1/3, what this means is we're taking the cubic root of negative 27. So again, y'all, I'm just going to back up here for a second. We know that the square root of 36 is equal to 6 because 6 times 6 gives us 36. And I want you to know we have two 6's, right? We're multiplying the number 6. We're multiplying it twice. So the square root means we're grouping in terms of 2. Now, when I see something like this, the cube root means I'm grouping in terms of 3. Okay, so what do I mean by that? If I were to take the number negative 27, I could say, hey, look, you know what? This is the same thing as negative 9 times positive 3. And negative 9 is the same thing as negative 3 times positive 3. Now, when I look at my numbers here, y'all, these numbers look real similar, except one of them is negative and the other two aren't. Notice what I'm trying to get to. I'm trying to get to a negative 27, right? But if I made this a negative and I made that a negative, I'm taking negative 3 times negative 3. That actually gives me a positive 9. But when I multiply it by that negative 3, I still get the number negative 27. The cubic root means I'm getting not doubles, but I'm getting triples. So what number do we have 3 of? Negative 3. Okay, so that's what we mean by like square roots, cube roots, fifth roots. You're grouping in terms of what that root is telling me to group in terms of, okay? So look, let's do one more. Let's do 625 to the power 1/4, okay? So look, 625 to the power 1/4, again, this means the fourth root of 625. Okay, so what am I doing here? I'm grouping in terms of 4. I want to get 4 of the same number. So the first thing I know is since it's 625, I know I can divide it by 5. Let me get my calculator. Let me turn this thing on, clear it. Let's go 625 divided by 5, 125. Okay, so this is 5 and 125. I can divide 125 by 5 again. That's going to give me 5 and 25. And we can break this up into 5 and 5. So notice 1, 2, 3, 4. So 625 to the power 1/4 is just 5 because we're grouping in terms of 4. Does that make sense? So that's all I'm really trying to do here, okay? All right. So let me go ahead and keep working here, you all, and I'm going to take a look at the next part. So the next part here, we're still dealing with our roots, but now instead of the power being like 1/3 or 1/2 or 1/4 or 1/5, now the power has both a numerator and a denominator, okay? So let me explain how I'm going to do some of these. Again, I'll just pick 2 problems. We'll go through them together, make sure that we're good. So why don't we pick something like, look at B. B has 32 to the power 7/5. Okay, that's a pretty big exponent, right? It's got a big number on the top, big number on the bottom. Let's see what this means. So 32 to the power 7/5 means I'm going to take the 5th root of 32. Once we do that, we're going to raise it to the 7th power. Okay, so just like we would do before, y'all, I'm going to deal with this part here first. So 32, remember what I'm doing here. I'm grouping in terms of 5. I want to get 5 of the same number. So I don't know about you all, but when I think of 32, I think of 4 and 8, because I know 4 times 8 is 32. And when I think of 4, I think of 2 and 2. When I think of 8, I think of 2 and 4. And again, when I think of 4, I think of 2 and 2. 1, 2, 3, 4, 5. So there we go. So I know that the 5th root of 32 is the same thing as 2, and now I have to raise that to the power 7. So what am I going to do? I'm just going to take my calculator, y'all, and I'm going to say, look, what is 2 to the power of 7? And I'm going to hit enter, and I'm coming up with 128. Okay, and remember, all this means here, y'all, is that we just took 2 times 2 times 2 times 2 times 2 times 2. I think that's 7 of them. And when we did that, we came up with 128. But we just did it using our calculator. But that's, in essence, that's what it's telling me to do. Okay. So look, let's do another one. Let's do, oh, I don't know. Let's try e, because the exponent is negative here. Okay. So in e, when the exponent is negative, look what we have. We have 16 to the power negative 3 over 4. So just to remind you all, if my exponent is negative, what this means is I'm going to rewrite it as 1 over 16 to the power 3/4, and my exponent becomes positive. So if I have a negative exponent, all I got to do is write it 1 over, and the exponent becomes positive. Now remember what this means here. So I'm going to go like this, because I still have my 1 on the top. When I have 16 to the power 3/4, this means I'm going to take the 4th root of 16, and all of that is going to be raised to the 3rd. Hello. Okay, so remember what the 4th root of 16 means, y'all. The 4th root of 16 means I'm grouping in terms of 4. Okay, so look, I'm going to take my number 16, and when I think of 16, I think of 4 and 4, but I know that 4 is the same thing as 2 and 2. So look what we have. We have 1, 2, 3, 4. So I know that the 4th root of 16 is the same thing as 2, but now that 2 is still being raised to the 3rd power. So remember what 2 to the 3rd power means, y'all. 2 to the 3rd means 2 times 2 times 2, and that's going to give me 8. So we end up with 1 over 8. Okay. So again, really what I'm trying to point out here is how do I handle these things when I have these kinds of exponents? Because we know what 5 squared is, and we know how to take the square root of 81. But sometimes when we see some of these numbers, we're not necessarily certain what does it mean, and that's exactly what it's telling me to do, okay? So let me check with those of you who are at home. Anybody got any questions so far? We're good. We still got Antonio, Claudia, and Lauren. Okay, excellent. As we're going through these problems here, y'all, those of you who are watching from home, are we doing okay? And those of you who are here, is this making sense? We're good so far? Okay. Just double checking. Guys, those who are at home, let me double check. I heard something in the chat. Yes, we're good. Awesome. Great. Okay, so look, let me go through a couple of these problems here, and then again, we'll go on to 4.3. And then y'all, like I said, if you have any particular homework questions, let me know. I'm more than happy to go over any of those, okay? So let's take a look here. We just have a couple of the rules for exponents. And so we're just going to see if we can match up some of these here. So I don't know, I'm going to pick I'll pick one from each. Maybe I'll say this one here, and let's say that one there. Okay, so look, the first one is 5 to the negative 3. So remember, the first thing I notice, y'all, is if my exponent is negative, the way I make it positive is I just write it as 1 over 5 to the 3rd. And remember what 5 to the 3rd means. 5 to the 3rd means 5 times 5 times 5, which is 125. Okay, so when I'm doing part A here, this is 1 over 125. That's going to get matched up with C, right? And then let's pick, say, another one. Let's pick, say, this one right here. Okay, so look, negative, parentheses, negative 5 to the negative 3. Okay, so we're going to go like this. Negative 5 parentheses to the negative 3. Again, the first thing is because that exponent is negative, I'm going to write it as 1 over negative 5 to the positive 3. So when I flip this thing here, y'all, the only thing that happens is my negative exponent becomes positive, but this number here doesn't change. It stays the same number, okay? So notice, look, if I want to fix this part, negative 5 to the third, that means negative 5 times negative 5 times negative 5. Well, when I multiply those together, these two, that gives me a 25 times a negative 5 is a negative 125. So this is going to be negative 1 over 125. Okay. And so when I look at part C, I'm going to say, you know what? That one gets matched up to D. Okay. All right. And I'll tell you what, let's do the same thing for this next part here. Okay. So first thing I'm going to do here, y'all, I'm going to choose, say, option B here. Okay. And it's negative 4 to the power negative 2, but notice there's no parentheses, right? So it's negative 4 to the negative 2. Okay, and I know I put my negative a little bit further away, but I did that because it's not inside the parentheses. So look, we already know how to do this. Because we have a negative exponent, I'm going to leave this negative over here alone. I'm going to write it right there. So 4 to the negative 2 just becomes 1 over 4 squared. And here's my negative again. Remember what 4 squared is. It means 4 times 4. So that's going to be negative 1 over 16. So I'm going to say that B is going to get matched with that one right there. Okay. All right, and then let's do part D. Let's do this one. Okay, so notice the difference between B and D. In B, y'all, we didn't have parentheses, and in D we do, right? We have parentheses there as well. So we're going to do this in pieces. So we're going to go negative, and then negative 4 to the power negative 2. Okay, just like I did before, I'm going to deal with this part first. So I'm going to leave this negative alone right here. This is going to become 1 over negative 4 squared. So remember, again, when I'm doing this, y'all, the only thing I'm doing is taking my negative exponent and writing it as one that is positive. Okay. All right, so let's take a look-see here. We know that negative 4, when we square it, negative 4 times a negative 4 is a positive 16. So this is 1 over 16. But remember, I still had that negative there. So my answer is negative 1 over 16. And so when I look at choice D, it is also going to, or little d, it's also going to get matched up with little d as well. All right. So that was just a little bit about exponents, y'all. And again, I wanted to go through some of those there so that we can kind of figure out what are we doing in these problems, and so we can kind of figure out how do I do the logarithm. Okay, so look, I forgot there was one more here. So let's just pick, I don't know, let's pick 2 of these here. And so from the first column, y'all, I'm going to choose, I tell you what, a lot of these problems look very, very similar. So I'm actually going to pick this one here, and we'll pick this one here, okay? Oh, you know what? Let's pick one that has a negative exponent. So let's pick D. Okay, so let's do A and D. So if we look at option A, it's 8 over 27 to the power 2/3. So again, just a friendly reminder, the denominator, y'all, refers to the root. So this is the cubic root of 8 over 27. Once we get that, then we're going to square it. The numerator tells me what the exponent is. The denominator tells me what the root it is. Since I'm dealing with the cubic root, I'm grouping in terms of 3. So look, I'm going to take the number 8. I'm going to divide it out. That's 2 and 4. 4 is 2 and 2. Look how many 2's we have. We have 3. That's all we're doing, grouping in terms of 3. So the cubic root of 8 is going to give me 2. And then I'm going to do the same thing for 27. So 27 is 3 and 9, but 9 is 3 and 3. And if you notice, I'm grouping in terms of 3. What number do I have 3 of? I have 3 3's, okay? So what we've done so far, y'all, is we've taken the cubic root of 8 over 27, and we came up with 2/3. Now, we still have to square it. So remember what it means to square something. It just means to multiply it by itself. So 2 squared is 4, and 3 squared is 9. So from number 10, my answer should be 4 over 9. So that's going to be choice B. Okay. All right. Now let's do this little d right here. We're going to do the same thing. So look, we have a negative, and then we have 27 over 8 to the power negative 2/3. Okay. So the one thing I want to emphasize, y'all, this exponent is referring to what's going on the inside. Okay. So the first thing I want to do here, y'all, is I'm going to rewrite this as negative, or I'll actually write it like this. Here's my eraser. Here we go. Okay. 1 over negative 27 over 8 to the power 2/3, right? Because since my exponent was negative, the way we make it positive is we write it as 1 over, okay? So look, we have to deal with this part. So we're going to write 1 over negative. Now let's see if we can write this part here. This is the cubic root of 27 over 8, and that's being squared. Okay? So, y'all, if we know what the cubic root of 8 over 27 is, do you think we can figure out the cubic root of 27 over 8? If the other one was 2/3, wouldn't this one just be 3 over 2? Right? So we're going to go like this. 1 over negative 3 over 2 being squared, right? Because, again, the cubic root means we're grouping in terms of 3. And remember, we had 3 2's and we had 3 3's, right? Okay, what does it mean to square something? It means to multiply it by itself. So 3 squared is 9, and 2 squared is 4, and I still have that negative there. Okay. All right. Now, remember what a fraction means, y'all. A fraction means we're dividing. So we're taking 1 and we're dividing it by negative 9/4. Okay. How do I divide fractions? We multiply by the reciprocal. So I'm going to think of 1 as 1 over 1, and I'm going to multiply it by the reciprocal of this number. The reciprocal just means flip it and put a 4 over 9. And 1 over 1 times a negative 4 over 9 should just be a negative 4 over 9. Okay. So we came up with our answer, and we're going to see, okay, which one does this one match up with? And it looks like it's going to match up with choice C over here, y'all. And I'm going to zoom in. You can see that a little bit, hopefully. There we go. Okay. Right there. Okay. So again, the one thing I really want to emphasize, y'all, is just understanding what does it mean when I have a power that's a fraction. The denominator, the bottom number in my fraction, is the root that I'm taking, and the numerator is the power that I'm going to raise it to. And whatever the denominator is, it just means you're grouping in terms of that number. So the one way I always explain this, y'all, and those of you who are here, it's probably easier for y'all because y'all are going to look at me. Those who are at home, just kind of use your imagination. But ever since COVID, I don't have a lot of money on me, like in my pocket. But if you have change, right? Say you know, when you're a little kid, mom comes home, dad comes home, they put change on the counter. You go and you take, say, or you have a piggy bank and you take quarters. When you take quarters, you probably go 1, 2, 3, 4. 1, 2, 3, 4. That's how you group your quarters, right? Because you're grouping them in terms of 4 to get $1. Or if you have, I don't know, dimes. Sometimes when you're a kid and you have dimes, you go 1, 2, 3, 4, 5, 6, 9, 10. 1, 2, 3, right? Or even with pennies. For pennies, most of us would go like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You're grouping them in terms of a certain number. That's all we're doing when we have these roots. We're grouping them in terms of whatever the denominator is. And we're trying to get the same number that number of times. So I'm trying to get, if I'm dealing with the cubic root, I'm trying to get sets of 3 of the same number. So when we did, let me come back over here. Here we go. When we were taking the cubic root of 8 over 27, we said, how can I break up the number 8 so that I have 3 of the same number? Why 3? Because we were taking the cubic root, right? And one of the problems we did earlier today, let me see if I can find it. It's somewhere over here. When we took the 4th root of 625, what were we trying to get? 1, 2, 3, 4 of the same number. That's all it means we're doing, okay? So again, if you can think about it in terms of like money, and when you group your money together, you group your pennies, you put 5 and 5 and 5, right? Nobody really did all their pennies. 1, 2, 3, 97. I mean, most of us didn't take our pennies and do them, right? We would group them in terms of 5. But that's really what those numbers really mean, okay? All right. So now that we went over a little bit of rules of exponents, let's go through 4.3, okay? And we're going to go through the whole section here, y'all, and see if we can't make sense out of this. And 4.3 is logarithmic functions. Okay, so what is a logarithm? So a logarithm, y'all, is just another way to write something as an exponent. So what we have here says y equals a log base a of x. That's how I read this here. So I'm going to write it out. Y equals the log base a of x. That's how I read this part right here. And that's equivalent to x. X is equal to a to the power y. Okay. That's how I read this part right here. Okay, so this number here, x, is going to be the same thing as the base number raised to that power over there, okay? So we're going to see if we can't figure out what's going on here in these problems. So what I'm going to do here, y'all, I'm going to do a little stare and compare. I'm going to look at this first part right here. So this first part says the log base 3 of 81 equals, I don't know, it's going to be some number. I don't know what that number is. So I'm going to call it y, just because that's the number we have over there, okay? So I want you to look at what I have right here, and I want you to look at what I have right here. Would you guys agree with me that my a is equal to the number 3? If I do a little stare and compare, like if I look at this part right here, and I said, look, here's my a. Well, my a is 3, right? And then my x is going to be the number 81. And let's see, I heard something in the chat, so let's come back over here. Lauren says we're good, excellent. Okay, so my x is 81, and what I'm trying to figure out is what is my power of y? Okay, so what we're going to do, y'all, we're going to write it like this. We're going to say 81 is equal to 3 to some power. And what we're trying to do is we're trying to figure out what that power is. So one way we can do this, y'all, let's break down the number 81. So I don't know about you all, but when I think of 81, I think of 9 and 9. That's just what comes to my mind, right? Because when we were kids, when you were in school, you know, elementary school, junior high, we had a multiplication table, 81. I always thought 9 times 9, right? They drilled that into us a whole lot. And 9, we know, is 3 and 3, right? So what I'm going to do now, y'all, is instead of me writing 81, I'm going to write 81 as 3 to the 4th is equal to 3 to the y. Well, if this number is equal to that number, right, 3 to the 4th equals 3 to the y, and if these numbers are the same, then my exponents also have to be the same. So what does my y number have to be? Excuse me. My y number has to be 4, okay? Excuse me, let me back up a little bit so you can see this. So notice what we're trying to do. We're trying to match the logarithm in column 1 with the value in column 2. So I would say for this one, it's going to get matched up, boom, right there. That's the one that it's going to be. Okay. All right. We're going to do the same thing for each of these problems here. So look, let's take a look at the next one here. We're going to say the log base 3 of 1/3 is equal to some number y. Okay? I'm going to do the same thing we did a little while ago, y'all. We're going to do a stare and compare. I know my a is still 3. My x is now the number 1/3. And I'm trying to figure out what my y number is. Okay? So look what we're going to put. We're going to write it so that it says my x number, 1/3, is equal to my base number, 3 to some power of y. Okay. Now earlier, y'all, we took in the first problem we had 81, and we just broke down 81 so that we could figure out what it was, right? But look at the number we have now. We have the number 1/3. So 1/3, y'all, I can think of 1/3 as 1/3 to the power of 1, okay? Because that's the power in my 3. Do you remember earlier today when we had negative exponents, and we said if we had an exponent that was negative, the way we would make it positive, we would write it as 1/that number. So 1/3 to the first power would be the same thing as 3 to the power -1, right? And if 3 to the power -1 is the same thing as 3 to the power y, then that's telling me that my y number has to be -1. So little b, y'all, is going to get matched up with big B. That's where that's going to go. Okay. And again, y'all, this is what I'm going to do. We got 4 more to go through, so I'm going to keep doing this. I'm just going to go real slow to make sure that I can figure out how to do every one of these. Okay. So let's take a look at the third one. It's the log base 10 of 0.01. Okay, so I'm just going to do this over here on the side. I'm going to write the log base 10 of 0.01. Was it 0.01? Yeah, we'll write it exactly as the way they wrote it. 0.01, and we don't know what it's equal to. We're going to say it's equal to some number y. So remember, y'all, my base number is always the bottom number. That's going to be my a. My x number is always going to be this number here, 0.01, and we don't know what the number y is, okay? So the logarithmic form, or the exponential form, y'all, says a to the power y is equal to x. So a is 10 to some power is going to be equal to this number here, 0.01. Okay, so whether you all are at home or those of you who are here with us in person, when we were back in school and we had like place values, so I'm going to kind of do this on the side a little bit, and I'm going to make something up here. Let me just pick a number, 23.05. Like think of this as $23.05. So remember, that's the tens position, right? That's the ones position. Anybody know what the first decimal place is? Anybody know what that first zero, that number there, what place value is it in? You know what I'm talking about? Like we have the tens, the ones, the hundreds, the thousands. This one here, y'all, is the tenths, like in terms of dimes, okay? And this one here is the hundreds with the TH at the end. And like in terms of pennies, right? Okay, so the hundreds means exactly what you think of. How many pennies does it take to get $1? It takes 100 pennies, right? So coming back to my problem here, the way I can write this in terms of a fraction, there is 1, and that's in the hundredths position. So it's 1/100, okay? And 10 to the y, let's see, 1/100, I can write that as 1/10 squared, because 100 is 10 squared. And just like we did earlier, if it's 1/, y'all, I'm going to write it like this. 10 to the power -2, because it's 1/, that, right? So then that's telling me that my y has to be the same thing as my number -2. Okay? So look, I'm going to zoom out, and I'm going to come back over here, And I'm going to say, look, choice C has to get matched with part A because there's my -2. Okay. So, yeah, a lot of stuff that I'm trying to go back and remember, like from like 8th grade math in terms of like place values and stuff like that, right? Because that was a long time ago. I don't know about you guys, but I was in 8th grade in like 1987. Some of you guys weren't even around here. So, okay, let me clean up this mess here just so we can get rid of it. Okay, so let's come back over here, y'all. We got a couple more to do. Let's do it. Let's see, the next one is the log base 6 of the square root of 6. Okay, so we're going to do that over here. Okay, the log base 6 of the square root of 6 is equal to some number y. Okay, so my a is 6. My x is the square root of 6, and I don't know what y is. All right. So remember, this right here, y'all, is the basic form that we're trying to write it in. We're trying to write it from the logarithmic into the exponential form, and then we can figure out what my power y is going to be. So I'm going to say a, which is 6, to the power y is equal to the square root of 6. Okay, so look, y'all, this is the square root of 6. Even though we didn't write it, does anybody know what's the number that goes right there? If it's the square root, what number goes there? Think of when you square something, you multiply it by itself how many times? 2, right? That's really what the number is right there. Okay, even though I don't see it, y'all, it's the square root, so that's what the number 2 is, right? Because that's the root that I'm taking. Now, earlier today, when we did the rules of exponents, we said there's a way that we can write roots so that they have powers that are fractions. And the way we would write this would be to the power 1/2. So again, since this part is equal to that part, the whole thing, and since the bases are the same, then the exponents are also going to be the same. So my exponent here, y'all, is going to be the power 1/2. Okay? So, y'all, that's why between 4.2 and 4.3, I added that section of rules of exponents, because when's the last time we ever looked at that stuff? Most of us hadn't, right? So that's why I kind of put that in the videos, and I made the notes, and I went over it right now, because I need that in order to be able to do my logarithm problems, you know? Okay, so let me come back over here, and we're going to say D is going to get matched with the letter D right there. And let's see if we can keep going here. All right. So we have the log base E of 1. Okay, so let me write that over here. Log base E of 1 is equal to some number y. Yes, ma'am. How did I get 1/2? Okay, so remember, if it's the square root, it's the same thing as the power 1/2, right? So anytime I have a root, whether it's the square root or the cube root or the 4th root or the 5th root, so just to give you an idea again, like if I have the 4th root of x, I can write this as x to the power 1/4. And if I have the square root of y, I can write this as y to the power 1/2. And if I have the cube root of z, I can write this as z to the power 1/3, right? So anytime I have a root, we can rewrite it so that it has a power, and the power is 1/whatever that root is, right? And so the one thing I do want to emphasize, and then we'll come back to the problem. If I write it like this, the square root of w, notice I didn't put a number right here, right? I didn't put a number on this one. When there's no number there, it's always understood to be 2. So this here would be w to the power 1/2, okay? If there's, very good question. If there's no number there, y'all, it's always going to be the square root, okay? If it is a number, then it'll be 1/whatever that number happens to be. Excellent question, very good. Okay, so let's take a look here, and I'm going to do the same kind of thing here, y'all. Okay, so again, I'm coming back to this equation right here, y'all. A to the power y equals x. So look, my a happens to be e. Let's see, my x happens to be the number 1, and I don't know what the number y is, okay? So we're going to say e to the power y is equal to my number x, okay? So I think, I'm going to double check, y'all. I'm going to double check, but I think I put it in the rules of exponents. So let me come back. I'm going to zoom out a little bit, y'all. And let me come back here, and let's take a look at some of the rules of exponents that I put for us right here. Okay, so here's some rules of exponents. I don't see it here, and I don't think I put it in this one either. No, we didn't. Okay, so let me just give you this one here, y'all. I'm going to write it here in my rules of exponents. Any number to the power 0 is going to be equal to 1 as long as that number is not equal to 0. 5 to the power 0 is 1. Negative 7 to the power 0 is 1. 1/3 to the power 0 is 1. The only one that I can't do 0 to the power 0. But every other number you can think of, if you raise it to the power 0, it's going to give you 1. Okay, so the reason why I'm putting this here, okay, is that now when I come to the problem that we're dealing with, and I wrote it over here on the left somewhere, here we go. We have this number e. E is an irrational number, y'all. We'll talk about it. We actually talked about it in 4.2 when we did the continuous interest. We saw that number e coming up, okay? But it's an irrational number. But if it's being raised to some power and it gives me 1, that tells you that that power has to be 0. Okay, it's going to have to be 0. Any number to the power 0 is going to give me a 1. So look, I'm going to scroll back over here, and I'm going to say, look, this one here has to get matched to D. And then look, y'all, by process of elimination, it looks like F is going to have to get matched up with E here. But let's go ahead and do it again, just to make sure we understand what's going on. So look, let me clean up some of this mess here, okay? And I'll just write it right here so we can kind of see what's happening. All right, so we have the log base 3 of 27 to the power of 3/2 is equal to y, okay? So remember, when I think about this here, y'all, my base number A is 3. My x number is this number right here, 27 to the power 3/2. So what we're going to say is we're going to say that 3 to this power is going to give me, excuse me, that number right there. Okay, so I'm going to say 3 to some power is going to give me 27 to the power 3/2. So the first thing I want to do here, y'all, I want to take a look at the number 27. When I think of 27, I think of 3 and 9. And when I think of 9, I think of 3 and 3. So would you all agree with me that 27 is the same thing as 3 to the 3rd because there's 1, 2, 3 of them? Okay. So look what we're going to do here, y'all. We're going to write it like this. 3 to the power y equals, instead of 27, I'm going to write it as 3 to the 3rd to the power 3/2. Okay. Now, this is in one of the rules of exponents, and I'll zoom back just so you can kind of take a look at it, but I'm going to come back to my rules of exponents right over here. Here we go. One of the rules says if I have a power and it's being raised to a power, we can just multiply the exponents together, okay? So look, let me scroll out here, and let me come back to our problem. Here we go. When we have a power being raised to a power, we can multiply our exponents together. So this is going to give me 3 to the y. If I multiply my exponents together, think of that little 3 exponent as 3/1. Just go straight across. 3 times 3 is 9. 1 times 2 is 2. 3 to the power 9/2. Okay? So remember, since this whole number is equal to that whole number, and since the bases are the same, then the exponents are going to be the same too. So my exponent here is going to be y equals 9/2. And so when I come back over here, look what we said. it was going to have to be that one because that was the only one we had left. So 9 over 3, okay? All right. So guys, it takes a little bit of time to kind of understand this. And I'm going to show you what I think is probably the best way of figuring out how to do these kind of problems here, okay? So look, let me scroll down and let me zoom in here and let's take a look at what it says here. It says, if the statement is an exponential form, write it as an equivalent logarithmic form. And if it's in a logarithmic form, write it in exponential form. Okay, so let me explain what I mean by that. I'm going to come back over here, y'all, and I'm just going to copy down this piece right here. Okay, the definition of a logarithm. So let me write that right up here for us. I'm going to erase some of this mess so that I can keep going back and referring to it. So it says y equals the log base a of x. Equivalent is just, it means the same thing as, okay? A to the power y is equal to x. Okay? And then this is what I'm going to do, y'all. This here is the log form, and this here is the exponential form, okay? And we know it's the logarithmic form because you can see it says log, right? And the other one, we can see that it's the exponential form because we have it as a power, and that's what exponents mean. Okay, so we're going to do a little stare and compare. We're going to look at this problem right here. Let me ask you a question. Would you say it's currently in the logarithmic form or it's in the exponential form? What do y'all think? It's in the exponential form, right? Because it's written kind of like the way this one is. Okay, since it's in the exponential form now, we're going to identify 3 parts. We're going to figure out what y is, what a is, and what x is. Okay? So look, if I do a little stare and compare, and I look at this part here, and I look at this part here, I'm going to say that my a is the number 3, my y happens to be the number 4, and my x happens to be the number 81. Okay? And all we're going to do, if it's currently in the exponential form, we're going to write it in the logarithmic form. So look, the first thing says, write down the number y. Well, the number y is 4. Is equal to the log of the base a. The base a in this case is 3 of what number? Of 81. And that's all you're doing. You're just going from one form to the other. And what this tells me is that 3 to the 4th power is going to give me 81. And look, that's what it says right there. 3 to the 4th power is equal to 81. So all I'm trying to do, y'all, is figure out what form is it in and then rewrite it using the other form. Okay? So look, let's do the same thing for the second problem. Okay, so first thing I notice, I'm going to look at this problem right here, y'all, and I notice that's also in the exponential form. So my a here is the number that I'm raising to the power, 2/3. My exponent y, the power is the number -3, and my x is the number 27 over 8. So now what I'm going to do is I'm going to write it using that form right there. So the first part says, write down the letter y. Well, the letter y is the number 3, equals the logarithm of the base a. The base a in this case, y'all, is 2/3 of the number x, which is 27 over 8. And we're done. Okay. Okay, let's take a look at the next one here. So first thing I'm going to do, y'all, I'm going to look at this part right here, and I say, look, this happens to be in the logarithmic form, okay? So I want to find my base number a. My base number a in this case is 6. My x number is the number right next to it. It's 36. And my y number is a number on the other side, and the number on the other side is 2. Okay, so I have that right there, y'all. And I know my a, I know my x, and I know my y. What I want to do is I want to write it like this, using the exponential form. So we're going to say our number a, which is 6, to the power of y, which is 2, is equal to my x number, which is 36. Those of you who are here, are we doing okay? Am I working? Are we doing okay so far? And then what about those of you guys who are watching from home? Are we doing okay? Let me stop sharing this real quick just for a second. Antonio, Claudia, Lauren, are we doing okay? We're good so far? Awesome. Excellent. Good, y'all. I just wanted to make sure we're good. Okay, so look, y'all, I'm going to have you do the next one together. Those who are at home, those who are here, I'm going to ask you a couple of questions. So if you're at home, you can just type in your answer in the chat box. And those of you here, if you got an answer, you can just tell me what you think it is. And so let's see. Here we go. Let's do the next one. So I'm going to zoom out just a little bit so we can all see. Okay, so look, y'all. Here is my logarithmic form. Here is my problem down here. And I'm going to ask you guys for a couple of things. Let me zoom out just a little bit. Okay. Anybody know what the number a is here? The little number? What's the little number a? And again, all you're doing here, y'all, is you are doing a stare and compare, and you're comparing it to this part. What do y'all think a is? Anybody know? Whether you're here or you're at home? What's the little number a? Look where the a is here. A is 2. Good. Okay. What about my x number? Look, the x number, y'all, is the number right next to the log. What's the number that's right next to the log? 8. There you go. Boom. You got it. I heard somebody put something in the chat. Just double check. Boom. You got it. Excellent. All right. What about my number y? Y is the number that we have all by itself. What's the number that's all by itself? There you go. Good. Okay. So look, now that we know what a is, what x is, and what y is, all you're going to do, y'all, is write this part here. You're just going to fill in the blanks. So the first part says a to the power y. So we're going to write what to what power? If we're going to write it as a to the power y, what should we put first? What's my a number again? 2. Good. To the power of y, which is 3, is equal to x, which is, and stick a fork in you because you are done. That's it. That's all you got to do. So a big part of this, y'all, is really going from one form to the next. So if you notice, when we did these problems here, even when we did the previous problems, I kept going back to that definition. I kept going back to when I see y equals log base of a, log base a of x, what does it mean? I don't know. Let me find my a. Let me find my x. Let me find my y. When we did these problems, the first thing I did is I wrote down that definition again. And I said, okay, what's my a? What's my y? What's my x? And in these 4 problems, all we did is go from one form to the other. That's all we were really doing, okay? Now, I'm going to show you in the next couple of problems, y'all, I'm going to do exactly the same thing, okay? So look, I got a couple of problems here, and it says solve each equation. Okay, so the first thing I'm going to do, y'all, I'm going to write this. I'm going to write y equals the log base a of x. And these little kind of double arrows it just means the same thing as. That's what that little double arrow thing means, okay? And I'm going to write it with the exponent form, a to the power y equals x, okay? So in these 2 problems that I have here, y'all, these equations are written in the logarithmic form. So these problems you hear are already written like this, and what I want to do is I want to write them in the exponent form, okay? So look, I'm going to do a little stare and compare. What would you say my a number is? What's the base number here? If I do a stare and compare, what's the little number that we have in our problem? The little number a. 5. Good. Okay. Now look at the number that's right next to it. The number right next to it is the x number. So the x number happens to be what? 1 over 625? And then we're trying to figure out what this number y is here. right? We don't know what it is. And in this case, they're calling it x. I wish they wouldn't do that because it gets confusing. So this is what I'm going to do, y'all. I'm going to scratch that out, and I'm going to put a y, okay? Just because I don't want to see the letter x twice. And hold on, which one is the x? You know what I mean? Okay, so look. Now that I know what my a is, what my x is, and we don't know what y is, I'm going to try to write it like this. So I'm going to say 5 to the power of y is equal to 1 over 625. So all I've done so far, y'all, is taken this thing here, and I wrote it again using exponents, okay? Now, since my number is 625, and I'm going to think of 625 right now, since it's 625, I know I can break it down. I can divide it at least by 5. So look, I'm going to take my calculator, y'all. I'm going to say, what's 625 divided by 5? Oh, it's 125. And I can divide that by 5 again, and that's 25. And I can divide that by 5, and it's 5 and 5. So let's look at something. 1, 2, 3, 4. So 625, y'all, is the same thing as 5 to the power 4. Okay, but I don't have 625. I have 1 over 625. So look, I'm going to write it like this. 1 over 5 to the 4th. Okay. And remember earlier today when we had some powers that had negatives, and when they were negative, we said we can write it as 1 over that thing, and it would become positive. So if I want to take this part here and rewrite it so that it has a negative exponent, I would write it like this. 5 to the power negative 4. So again, if these numbers here are the same, then the exponents have to be the same. So when I come back over here and I look at my problem and it says solve for it, I'm going to say the answer is negative 4. Okay? Because that's all I'm really doing. Does that make sense on how I'm able to figure that out? That's all we got to do. Okay? So look, let's take a look at the next problem here. I'm going to zoom in just a little bit so I can do a little stare and compare, y'all. So look what we have here. We have the log base x of 1 over 32 equals 5. Okay, so look, we're going to do a little stare and compare. We're going to look at this part here, and we're going to look at what we have over here, because right now it's currently in the logarithmic form. So my base number a, they're calling it x, but again, I don't want to use x because we already have an x in my problem. That's what it is we're trying to find. We're trying to find what that base number is, okay, because there's no number there for us, okay? But my x number, which is the number right next to that, in this case happens to be 1 over 32, and my y number, which is the number by itself, is 5, okay? So now that I have this part right here, y'all, what I want to do is I want to use the exponential form to write it out. So I'm going to say a, because I don't know what a is, to the power y. A to the power 5 is equal to 1 over 32. Okay, so let's see if we can't figure this thing out here. Okay, 1 over 32. When I think of 32, y'all, and I know I did this earlier, I'm going to actually do this a little bit on the side where I have some more room, and I'll come back in a second. When I think of 32, y'all, I think of 4 and 8. And when I think of 4, I think of 2 and 2. And when I think of 8, I think of 2 and 4. And when I think of 4, I think of 2 and 2. 1, 2, 3, 4, 5. So 32 is the same thing as 2 to the power 5. Okay? Notice what I'm doing. I'm breaking down my number until I can't break it down anymore, right? So look, y'all, I'm going to scroll back to where we were, and I'm going to say, look, a to the 5th is 1 over 32, but 1 over 32, we already said was 2 to the 5th, right? Now, this part here looks a lot like this part, but they're not exactly the same. A to the 5th, I can rewrite this part, y'all, as 1/2 to the 5th. I can think of that as 1 over 2 all raised to the 5th power. Just think about it this way. 1 to the 5th power just means 1 times 1 times 1 times 1, still 1. 2 to the 5th power, 2 times 2 times 2 is going to give me 32. So now, if I know that the whole thing is the same and the exponents are the same, then my a has to be the number 1/2. Okay? And so we found our base number. That's what we were looking for. We were trying to find that number right here. So we found it, and we said this is going to be the number 1/2. Okay? So again, in every one of these problems, what I'm going to do is I'm going to look at it in logarithmic form, and I'm going to figure out how to write it in the exponential form so that I can find my missing piece. Okay? So look, notice the next problem, y'all, is very similar to the one that we just did. So look, I'm going to rewrite the definition again. Y equals the log base a of x. Remember, the double arrow just says it means the same thing as a to the power y is equal to x. Okay. So look, I'm going to do a little stare and compare again. A, we don't know what it is. So I'm going to put a is a question mark. I don't know what it is. Okay, that's why they put the x there, because that's what we're trying to find. My x number happens to be 25. And my y number happens to be the number -2. So far, am I doing okay? Adidai, am I doing it right here with you? No, did I lose you? Okay, let's go back and let's make sure. Let's see. I heard something also in the chat. Claudia, we're doing okay. Okay, great. So Adidai, let me just kind of explain what it is I'm doing. Okay, I'm looking at this part right here, and I'm comparing it to this part right here. Okay, so look, here's my number a. See how there's an x there? So a, that just means I don't know what it is, right? Then right here is the x number, and the x number here is the 25. So x is 25. The y number is the number that's by itself. Okay. Now we're doing better? Okay, great. Now that we know what this part is here, I'm going to rewrite it using this part here. Okay? So look, we don't know what a is. I'm going to leave it alone. Y is the number -2 equals x, which is the number 25, right? So far, am I good? Okay, great. Now, what I'm going to do, 25, remember, 25 is the same thing as 5 times 5, right? Okay, so we're going to go a to the -2. Instead of 25, let's write it as 5 squared. So far, so good? Okay. Now, the exponents are almost the same. One of them is a +2. One of them is, what, a -2? Okay. If I took this part here and I wrote it as 1/5, see how my exponent right now is positive? If I bring it to the bottom, my exponent is going to become negative. Just like before when we had a negative exponent, when we wrote it as 1/, it became positive. If it's positive, when I write it as 1/, it's going to become negative. Okay? Now, we're kind of close. Anytime I have 1/, we can write it like this. So a to the power -2 is 1/5 to the -2. If it's a 1/, you can include the 1 inside those things. Now remember, y'all, if this whole number is equal to that whole number, and the exponents are the same, then this number here is going to have to be equal to that one there. So we would say a is 1/5, and I think I heard something going on here. Claudia, tell me, let me stop sharing the screen real quick, or maybe I'll share it this way so you can see what's happening. Boom, boom. Okay. So Claudia, you can, if you want to turn on your mic, you can turn it on. If you want to put it in the chat, you can put it in the chat, whatever's easier. I saw you had your hand up, Claudia, so I'm just trying to get to your question. Claudia, are we good? Oh, you got a question? Let me make sure I got my speaker on. Ah, okay, your audio's off. So there's a little mic down here. I don't know if that works or not, the little mic icon at the bottom, but I don't know if you have a question or did I lose you somewhere? Okay, good question. All right. Yes, let me show you real quick. So let me come back here, y'all. Okay, so let me get my pen going. Here we go. Okay, so I'm going to come back over here, y'all. If I have 5 squared, I can write it like this. 1 over 5 to the power negative 2. Earlier today, y'all, we did problems like this. I'm going to make this up. 3 to the power, like say, I don't know. If this is a negative 2, we can write it as 1 over 3 squared. Okay? So if I have an exponent that's negative, the way I can make it positive is I can write it as 1 over. The same thing happens, y'all. If I have an exponent that's positive, I can make it negative by writing it as 1 over like that. So and the reason why I did that, and I'm going to come back over here, Claudia, is because my original problem here, y'all, this part had, oops, let me get my pen going, here we go. This part had a negative 2. I wanted to make this exponent also being a negative 2. So if I have 5 squared, I can write it as 1 over 5 to the power negative 2. Anytime I have a 1, I can include that in my parentheses, okay? Because 1 to any power, y'all, is still going to give me 1. And then since the whole thing was the same and the exponents were the same, then we could say those numbers would also be the same. And that's how I came up with my A was 1 over 5. So that's okay, Claudia. Does that make sense on how I came up with the 1 over the negative 2? Yeah, okay, perfect. No, that's excellent question. I'm glad you asked because, again, I want to make sure you're doing okay with this stuff here. Okay, so let me keep going here. Let's see. And let me pull up. Let's keep working here, y'all. Oh, come on, pen. And there was one more here, and then we'll talk a little bit about properties of logarithms. Okay, so look, y'all, I'm going to copy this problem over on the side just because I'm running out of room here. So it's the log base 4 of x is equal to 3. Okay, so let's write it over here. We have the log base 4 of x is equal to 3. And the first thing, y'all, I'm going to do is copy down the definition of the logarithm. Okay? So one thing I want to emphasize, y'all, whenever you're doing your homework for 4.3, and just a friendly reminder, y'all, all this stuff is due by Thursday night. But whenever you're doing this stuff here, right, between now and Thursday, whenever it happens to be, you know, obviously you're entering your answers in my lab, but you're having to work everything out, okay? So every single time I would write this piece right here, y'all, on a paper somewhere. You can write it above every problem, whatever it is. But that's going to be my reference. I'm always going to go back and I'm going to look at that little definition, okay? So look, we're going to do the same thing we did before. My A, this is my A here. My A is the number 4. My X, I don't know what it is. My Y number is the number that's by itself, which is 3, okay? So that's always going to be my first step. I call it stare and compare. Stare and compare. Because all you're trying to do here is looking at the thing, okay, what's my A? Oh, what's my X? Oh, what's my Y, right? So I'm staring and comparing, trying to figure this part out. All right, now that I have that, I'm going to write it like this. So I'm going to say A, which is the number 4, to the power Y, which is the number 3, is equal to my X number, which I don't know. But I know how to find 4 to the third. 4 to the third just means 4 times 4 times 4, and that's going to give me 64. Yeah, I'm done, right? But that's what I'm going to do every single time, y'all. I'm going to just use this definition. I'm going to do my stare and compare so that I can figure out what's my A, what's my Y, what's my X. And if I don't have it, I'm going to say it's a question mark. That's what I'm trying to find, okay? And then I'm just going to go ahead and fill in the pieces and see if I can find that part that I don't have, okay, by doing that. All right. So look, let's come back over here, y'all. And we have some properties of logarithms. Okay. So properties of logarithms. Let me sort of explain what these things are referring to. So remember, y'all, I'm going to write down my definition again. Y equals the log base a of x is the same thing as a to the power y equals x, right? Okay. Do you remember when we're multiplying exponents? Like, I'm going to make this up. If I have x squared times x to the third, do you remember what we do with the exponents when we're multiplying? Anybody remember what we're supposed to do with those powers? Like x squared times x to the third, we actually add them together, and that gives me x to the fifth, okay? So I want you to notice something. Look, remember logarithms? Think about logarithms in terms of powers. Let me come back to the chat box because I heard something here. Add them. Very good. Thank you, Claudia. Excellent. Okay, so remember, think about when we're multiplying exponents. What do we do with each of those exponents? Hey, we add them together. That's why the property says the log base a of x plus the log base a of y, okay? Now, look at the next one, quotient property. So think about something like this, x to the seventh divided by x to the fifth. This would be x to the second. What did I do? We subtracted them. Anytime you're dividing powers that have the same base, what do we do with the exponents? We subtract them. I want you to notice something over here. Look at this property. I'm taking the logarithm of a quotient, then I'm going to subtract each of those individual logarithms, okay? And then there's something called the power property. So let me explain the power property, y'all. If I have something like x squared to the third, remember what we do with our exponents? We multiply them together. So if I have something being raised to a power, what am I going to do? I'm going to multiply it by that power. And that's why there's that r right there hanging out in front. It's being multiplied, okay? The logarithm of 1, y'all, is always going to be equal to 0. Think about what's going on here. If I look at this part here, y'all, and I look at this part here, okay? Well, my a is still a. My x is the number 1, and my y is 0. And if I think about it this way, it's going to say a to the power 0 is equal to 1. And that's something that we had mentioned earlier today when I said, well, you know, it wasn't in the rules, so let me go ahead and write it down. Any number to the power 0 is going to be equal to 1, okay? And the log base a of a is equal to 1. So again, let me explain what this means using, again, my definition of a logarithm. So my a is still a. My x number, which is the number right next to it, is also the number a, and my y number happens to be 1. So this is going to say the base number a to the power of 1 is equal to the x number, which is also a. Okay? That's all that those things are telling us. Now, I'm going to show you, again, I know I'm kind of going quickly through them here, y'all, but I'm showing you this part so that I can apply those principles as I do the next couple of problems, okay? The one thing I want us to remember is that if we're multiplying exponents, we add them together. If we're dividing exponents, we subtract those powers. And if we have a power being raised to a power, we're going to multiply those together, okay? So let me show you what I mean by this. I'm going to scroll down here, and it says, use the properties of logarithms to rewrite each expression. Simplify the result if possible. Assume all variables represent positive real numbers. Okay, so I know it's not written like this, y'all, but this is supposed to sort of be in parentheses, okay? So we're taking the log base 2 of 6x over y. The first thing I see here, y'all, is a fraction. Remember what a fraction means. Fraction means I'm dividing. And if I'm dividing exponents, then I'm going to subtract their powers. So I'm going to write this as the log base 2 of 6x minus the log base 2 of y. Okay? Now, the next thing I want you to notice, those right there are actually being multiplied. When I'm multiplying powers, I actually add the powers individually. So I'm going to write this as the log base 2 of 6 plus the log base 2 of x minus the log base 2 of y. And that's all we're really doing here. We're just breaking that part up, okay? We're just breaking that part up, okay? All right, so let's take a look at the next one. We're going to go about it the same way. Again, y'all, I'm going to come back over here, and I'm going to think of this as it's all one big expression, okay? Just like we did before, the first thing I noticed, like, hey, you know what? I see a fraction here. This means I'm dividing. So if I'm dividing, I'm going to subtract my exponent. So I'm going to write this as the log base 5, or I'm sorry, the log base 5 of 5 square roots of 7 minus the log base 5 of 3. Okay, because since I'm dividing, I'm going to subtract them individually. Okay, and then just like we did before, we said, look, hey, you know what? I'm multiplying these here. So I'm going to write this as the log base 5 of 5 plus the log base 5 of the square root of 7 minus the log base 5 of 3. Okay. All right, so I'm almost done here. I'm going to come back over here, y'all. I'm going to look at one of the properties. It was one of the last ones we did. Look what it says here. The log base a of a is equal to 1. So the log base 5 of 5, that's going to be equal to 1 plus the log base 5. Since this is the square root of 7, remember how I can write the square root of 7 so that it has a power? It's the power 1/2 minus the log base 5 of 3. Okay. Last step, I'm going to leave this one alone. If we have something that's being raised to a power, that power is going to get multiplied. So I'm going to put the power in half, and the power 1/2 is going to go in front. 1/2 times the log base 5 of 7 minus the log base 5 of 3. And right there, we are done. Okay. And so the idea here, y'all, is we're expanding this logarithm out. It's the logarithm of a single expression, and then we're breaking it up into like multiple parts, okay? So I think there's just a couple more problems here. Just a couple more here, y'all, and then we'll be done with 4.3s. We just got about 4 more problems. Okay, so let's take a look at this next part here. It says, write each expression as a single logarithm with a coefficient of 1. Okay, what's important here, y'all, it says we're going to go as a single logarithm. So right now we have multiple parts. We're going to write it as 1. Okay, the first thing I'm going to do, y'all, I'm going to look at these two pieces right here. And I notice, hey, look what I have in the front, and sorry, in the middle. I'm adding them. Remember what we do when we add exponents? It's because we're multiplying those two things together. So I'm going to write this as the log base a of xy minus the log base a of m, because that's the other letter that we got there. Okay? So because those two are being added, we multiply these two together. The second thing I notice is, look, we're subtracting. Remember when we subtract exponents? We subtract exponents because we're dividing those two expressions. So I'm going to write this as the log base a of xy over m. Okay. All right. Let me do the same thing with this next one here. Okay, so I'm going to just rewrite it so it's a little bit bigger, y'all, and I can work with this on my computer. Minus the log base a of n minus the log base a of t. Okay, so the first thing I notice here, y'all, both of these here have a minus sign. So what that means we can do is we can factor out that negative. And if we factor out the minus sign, then both these signs now become positive, okay? because we factored a negative out. And since we factored a negative out, and I say, look, what am I doing with those two things? I'm adding them, right? When do I add my exponents? When I'm multiplying my expressions together. So I'm going to say, look, this is a log base a of m minus, I'm multiplying these two parts together, the log base a of nt. Okay? Because they were being added, we add our exponents when we're multiplying the expressions together. Okay? Now, the next thing I notice is, hey, look, we're subtracting. When do we subtract exponents? When we're dividing the two expressions. So this is going to give me the log base a of m all over nt. I'm taking this guy here, and we're dividing it by that part right there. And again, remember what the direction said? The direction said, can we write it as a single logarithm? So here's one logarithm, here is one logarithm, right? That's what they mean by writing it as a single logarithm. We're going to write it as just one. You should only see the log one time, okay? So anytime it tells you to write it as a single logarithm, in your final answer, you should only be writing the log just once, right? You might have more parts inside, and you should have more parts inside, but the log should only be written the one time, okay? All righty. And the last part here, y'all, says there is a theorem on inverses. And it tells me that anytime my base number a is positive, but it's not equal to the number 1, if we have a to the log base a of x, it's just going to be equal to x. So this is what we mean by inverse. This part here is going to cancel out. All we're going to be left with is the x, okay? Or if we have the log base a of x, this is going to cancel out. All we're going to be left with is the x, okay? So look, we're going to do a little stare and compare. So here I have x equals the log base 3 of, or 3 to the power of log base 3 of 8. So let me zoom in because I know it's kind of hard to see. So I want you to look at this part right here, y'all, and look at this part right here. So my a is 3, right, because I have the 3 here and the 3 here, and my x is 8. So these are going to cancel. I'm just going to be left with x is equal to 8, right? They're undoing each other, okay? It's kind of like squaring something and then going back and taking the square root. It's going to undo it. All right, same thing for the next one. The 2 being raised to the power log of 2 is going to cancel out. We're just going to be left with 9. Okay? And so that there, y'all, is all of 4.3. So we still got about 20 minutes left. I don't know if anybody has any homework questions. Lauren, I want to say that you told me earlier you had some homework questions from 4.2. So Lauren, if you're still with us, do you know which questions you had from 4.2, Lauren, if there's anything you want me to go over? And those of you who are here, Laura, you have a question? Later in chapter 4, yeah, later in chapter 4, we're going to come back and we're going to be able to apply it like this inverse theorem. So right now we're just trying to show that they're going to cancel out, but we'll apply it when we get to like 4.4, 4.5, 4.6. So let me see. Lauren, number 3 from 4.2. Okay, so look, y'all, give me one quick second here. Let me stop in this part here. Let me come to our class. Let me get MyLab opened up for us. Let me click on assignments right here. And let's get to number 3 from 4.2. Here we go, 4.2. Question number 3. And let me open this up the entire way. Here we go. And let me make sure that those of you guys who are watching from home, can see this. So let me share my screen with you guys so y'all can see what I'm looking at. And here we go. Okay. So here's our problem. It says g of x is equal to 1 over 7 to the power x, and we want to find g of 2. So let me go ahead and just do a little copy and paste here, y'all. So let's go like this. Let's copy this. Let's open this up over here. Here we go. Okay. so here we go, y'all. I want to make sure that those who are watching at home, yes, you can still see. Great. Okay, so g of 2. Remember what this means, y'all. Everywhere we have the letter x, we're going to plug in the number 2. So g of 2 is going to be 1 over 7 squared. And 1 over 7 squared just means I'm going to take 1 over 7 times another 1 over 7. So 1 times 1 is 1, and 7 and 7 is 49. So my answer should just be 1 over 49. Let's double check to make sure that I'm not poking you guys in the eyes here. 1 over 49. We're going to go chickadee check, and we got it. Lauren, any other questions here from 4.2? Let me stop sharing that real quick, and then I'll come back and pull something else up. And if those of you who are still watching, I'll pull it back up so you can see in a minute. No, you're good. Any other questions anybody has from 4.2? Anything? You want me to just do one more just to make sure we're good? Oh. On 4.3? Which one is it? Number 1. Okay, so let's do this, y'all. Let's go to 4.3. Let's do number 1 from 4.3 and make sure that we're okay. So look, let me come back over here, y'all. So I'm going to click on assignments. Let me go to 4.3 and let's do question number 1. Here we go. Let me open this up I'm sorry, number 2? Okay, it was number 2. So here we go. Okay. So what we're going to do here, y'all, we're going to do, again, I'm going to do a little copy and paste. Okay, so let me copy this here, and then let me paste this over here. Okay, so look at the directions, y'all. It says write in the logarithmic form. I know somebody put something in the chat, y'all, and I will check that in 1 second here. Okay, so remember what I told y'all. If I was sitting where you're sitting, right? If my teacher's name was Mr. Rodriguez, this is what I would do. The first thing I would do, y'all, I would just write down this definition, okay? You don't necessarily have to memorize it, y'all, but just, go back to the notes, look for it in the video, and then write it down and have it in your notebook somewhere so that as you're going through the problems, you can keep sort of writing it. Okay, so they want me to write it in this form because the directions say write it in the logarithmic form. So right now, we're in this form here, y'all. So look, we're going to do a little stare and compare. I want to find my A, my Y, and my X. So if I stare and compare and I look at this part here and I look at this part here, I say A is 5. I'm sorry, you know what? I'm probably not sharing it, right? That's probably what it is. Yep. Sorry about that, y'all. My bad. Yeah, I'm pulling it up right now. I'm sorry about that. Okay, so sorry about that, y'all. Those of you who are from home, yeah, I wasn't sharing the screen. Okay, so those of you who are watching from home, let me just kind of explain what I'm doing again. So the first thing I did, y'all, is I wrote down the definition. Okay, I think you guys can see it now. I wrote down the definition, right? And the directions are telling me to write it in logarithmic form. So I want to put it in this form is what my goal is. So right now, this thing here looks like this. So the first thing I'm going to do is I'm going to figure out what is my A, what's my Y, and what's my X. So as I do my stare and compare, I say A is 5, Y is also 5, and X is 3125, right? So now that I have that, y'all, I'm going to write it so that it looks like this. So the first thing says Y. Y is 5 equals the log base 5, because that's my base, of 3125, right? And so this is what I'm going to write out. 5 equals log base 5 of 3125. So look, let me pull up the problem so we can see. Okay, and now look at the way they have it written here, y'all. And I'm going to pull up my notes again. So the only thing that's different is we just kind of have it switched around, right? So I would write it like this: log base 5 of 3125 equals 5. And all I did is just, flip them over, right? But it's the same kind of thing. Okay, so now I'm going to come back to my problem. I'm going to say the log base 5 of 3125 is equal to 5. I'm going to go chickadee check, and we got it. Does that make sense how I'm doing this? Yeah, we're good? So look, y'all, let's do one more just to make sure that we're good here. Okay, so it says, write the given statement in equivalent logarithmic form. Okay, so look, y'all, I'm going to do a little copy and paste again. And again, what I want to show y'all is, again, the idea and how would I do these problems. So if I was sitting where you're sitting, how would I do this, right? So oops. Scroll over here. Okay. Okay, so here's the question, right? So again, y'all, if I was sitting where you're sitting, so if my professor's name was Mr. Rodriguez, then what I would do, the first thing is I would write this. Okay, so look what it says. Write the given statement in equivalent logarithmic form. So again, the first thing I'm doing, y'all, I'm copying down the definition. Okay, so right now, this piece here looks a lot like this piece here. So my A is the number 2/3. My Y is the power, which is -2. And my X is the number 9/4. So far, am I doing okay? Okay. And guys, all I did here, y'all, those of you who are here, those of you who are at home, all I did, stare and compare, right? It's just a stare and compare type part. Okay, so now that we have that, we're going to write it so it looks like this. We're going to say Y, -2, equals the log base A, 2/3 of X, which is 9/4. Okay, so now that I have this part here, I'm going to look at my answers, A, B, C, and D, and I'm going to say which one of my answers, A, B, C, and D, looks most like this one, and I would have to say D, right? Look, log base 2/3 of 9/4, log base 2/3 of 9/4 equals -2 equals -2. So my answer is B. So again, those of you who are watching from home, I think you can see this too. I'm going to go like that. I'm going to go chickadee check. And hey, I'm starting to get a real nice warm feeling here in my panza. Not because I had spicy carne asada, but because I'm getting the problems right. You know what I mean? So again, this is really all I'm doing, y'all. I'm just going to go from one form to the other. So look, let me do one more. So let me copy and paste again. Right? Okay, so let me go copy here. Let me come back to my notes. Let me paste this over here. Okay, so look what it's telling me. It's telling me to write this thing in exponential form. Okay, remember what we said earlier, y'all? The first thing I'm going to do every single time is do this. This is always going to be my step, okay? So I'm looking at my definition. Okay, so first thing I'm going to do, I'm going to say, look, right now we're in this form. So my A should be my number 7. My X should be my number 49. And my Y number should be the number 2. And all I did, y'all, again, was stare and compare, right? Now, they're telling me to write it using exponents. So I want to write it like this. So I'm going to say A, which is the number 7, to the power of 2 is equal to my X number, which is 49. And that's exactly what I'm going to type in here. And it says, look, type my answer using exponential notation. Don't simplify. So this right here, y'all, is exactly what I'm going to write. I'm going to come back over here. I'm going to say 7 squared equals 49. And I'm going to go chickadee check. Boom, we got that one. What do you think? Is this making sense? Yeah? I'm going to check in with you guys at home, so I know this is looking a little off here. Let's see. Okay, so let me stop sharing that real quick, y'all, so that it doesn't look so weird. But those of you who are watching from home, Claudia, Antonio, Lauren, were those problems, those that we just did that make sense? We're good? Okay, excellent, great. I just want to check. So we're good so far? Awesome, great, guys. So look, we still got 10 minutes. You want to keep rolling through the problems? Let's roll them through. Maybe we can knock out, maybe we can, number 4.2, number 6. Claudia, definitely. So look, let me go back. Let's do 4.2, number 6, but we've already done a few from 4.3, and I think you guys are getting the hang of it, right? And again, y'all, that using that definition, that's all I'm going to do with every single one of these problems, right? But let's pull up number 6 from 4.2. And so let me get out of here real quick. And those who are watching at home, I'm going to go ahead and share my screen so that you guys can see it. And okay, so let's come back. Oops, where are we? Here we go. Let's come back over here. And let's get 4.2. Let's do number 6. Here's number 6. And let me pull this up here. Excellent. Let's go ahead and do this one too. So this is 4.2, number 6. Okay, so let me go ahead and copy this guy here. And I'll tell you what, let's do this one over here where we got some room. Oops. There we go. Okay, so I think, can you guys see this from home? Yes, I think you can. Boom. Yes, okay, perfect. Okay, it says solve the equation for x. So 3 halves to the power x equals 8 over 27. Okay, so look, let me write it again. 3 halves to the power x equals 8 over 27. Okay, first thing I'm going to do, y'all, I'm going to break down the number 8. 8 is 2 times 4. 4 is 2 times 2. So 8 is the same thing as 2 to the third, okay? And then I'm going to do the same thing for 27. So 27 is 3 times 9. But I know that 9 is the same thing as 3 times 3, right? So 27 is the same thing as 3 to the third as well, okay? So now let's take a look here. So the first thing I'm going to do, y'all, I'm going to write it like this. 3 over 2 to the power x equals, let me zoom out a little bit so we can see everything. Since 8 was 2 to the third, I'm going to write this like 2 to the third, and 27 was 3 to the third, okay? And so now the next thing I'm going to do is I'm going to say, look, 3 over 2 to the power x is equal to 2/3 to the power 3, because they're both being raised to the power 3. We can think about it as one big fraction being raised to the power 3. Okay, so y'all, this is what I'm trying to get to. I want this part here to look exactly like that part there. And they kind of sort of look alike, but they're not exactly. One number is the reciprocal of the other one. So this is what we're going to do. We're going to leave this as 3 over 2 to the power x. We're going to go ahead and take the reciprocal of this guy. The reciprocal just means that we are going to flip it. So earlier, Claudia, do you remember when you asked me a question? I'm going to see if I can come back over here. I'm going to see if I can find it. Oh, where did it go? Where did it go? Where did it go? Oh my goodness, it was somewhere over here. And I'm trying to see where we wrote it. And I think it's somewhere over here. And it had to do with a -2. Yes, here we go. And I told you guys right here, I told you guys that if I have a power and I write it as 1 over, or I take the reciprocal, my exponent becomes negative. So look, when I come back to my problem, let me get back to my problem, see if I can find it. Here we go. Since we took the reciprocal of this thing, my exponent, y'all, becomes negative, okay? If I flip that fraction, that exponent inside, then my exponent on the outside is going to change signs, okay? Now that we have that, since the base numbers inside are the same, and the whole part is the same, then my exponent is also going to be the same. So my exponent here is going to be x equals -3. And I'm going to come back to my problem. I'm going to pull it up right here. And I'm going to say my answer here is -3. And I'm going to check it. And we got it. Okay. Let's see. Let's try this one, y'all. It's a different problem, but let's go and try it. Again, we got some time. We still got about 5 minutes. And I just want to make sure I can answer as many questions as you guys have before our time is up. And then y'all, those of you, again, who are at home, those of you who are here, remember y'all, you can always message me like, hey sir, can you do this one here? Can you do that one? And you know that I'm always going to tell you, yes. Yes, we can. Okay, so look, it's telling me to solve the equation. So 2 to the power 2x minus 7 is equal to 16. Okay, so I'm going to just write down the problem again. 2 to the power 2x minus 7. Okay, first I'm going to do, before I rewrite it, y'all, 16. I don't know about you guys, but when I think of 16, I think of, say, 2 and 8. You can say 4 and 4. It doesn't really matter as long as the numbers actually multiply to 16. Like you couldn't put 3 times 4, because 3 times 4 is 12, and you're trying to get to 16. Okay? And look, 8 I know is 2 times 4, and 4 I know is 2 times 2. I'm going to count 1, 2, 3, 4. So instead of me writing 16, I can write 2 to the 4. Okay? So now that we have that part, since the base numbers are the same, y'all, and since this whole piece is equal to that whole piece, then the exponents have to be the same. So that means that 2x minus 7 has to be equal to 4. The exponents have to be the same, okay? So look, we can say, look, let's add 7 to both sides. And I'm going to come up with 2x is equal to 4 plus 7 is 11. And then we're going to divide both sides by 2. And we come up with 11 over 2. Okay? And so look, I'm going to come back to my problem, and right here, y'all, I'm going to type in 11 over 2. And we're going to go check. And we got it. Okay. All right. You want me to try this one too? Yes? Okay, let's do it. So look, y'all, let me do a little copy and paste again. Okay, so let's go copy right here. Let's come back over here and let's do a little paste. Boom, there we go. Okay. All right, y'all. This problem, I'm going to do it exactly like the one that we just did right now. Okay, first thing I noticed, I have 81 and I have 27. So look, let's take 81 and let's break it down. Again, I told y'all, when I think of 81, I think of 9 and 9, right? And each of those 9s has 2 3s. So do y'all agree with me that 81 is the same thing as 3 to the power 4? Okay. So right here, y'all, look what I'm going to do. Instead of writing 81, I'm going to write 3 to the power 4 to the 5x. Okay, because I still have that 5x on the outside. Now, 27, we already broke up 27 earlier. Didn't we say 27 was 3 to the third? Okay, so look, let's go like this. We're going to say this is equal to 3 to the third, and all of that is being raised to the power x plus 3. Okay. Now, a little while ago, y'all, we said that when we have a power being raised to a power, what we do with the exponents is we find. So I'm going to take these exponents here, y'all, and I'm going to multiply them. That's going to give me 4 times 5x, 20x, right? I'm multiplying my exponents. Equals 3. I got to multiply these exponents. So y'all, think of that x plus 3 with parentheses, and we're going to distribute that 3 to both parts. So that's going to give me a 3x plus 9, okay? Now, remember how we did the problem before? I'm going to come again. Remember how we did the problem before? We said, look, if these numbers were the same and the base numbers were the same, we just took the exponents and set them equal to each other. We're going to do that here. The whole numbers are the same. The bases are the same. So we're going to say 20x is equal to 3x plus 9. And now we can just solve for x. So we can say, look, let's go minus 3x and minus 3x. So those are going to cancel. That's going to give me a 17x equals 9. And then we're going to go ahead and divide both sides by 17. and x is equal to 9/17. And so look, we're going to come back over here, and right here, y'all, we're going to put 9/17. We're going to check it, and we got it. Okay. Okay, so I'll tell you what, y'all. I know we're running out of time. I know our time is up. Let's go ahead and do this problem here, just so that you can see again how they're done. And I know I sent out a video. I think I sent out a video about one of these. I don't know. I know I did it maybe one of my class sessions. So I may not have sent out a video, but I know I did this problem. But let's go ahead and do this one here. I don't want to keep you guys any longer than you need to, but I want to make sure that we can answer these types of problems as well. So let me just do one more, and then we'll call it a night, okay? Let's see, here we go. Let's go ahead and paste this one here. Okay, so this is number, whatever number it is, number 9, something like that. Yeah, it's question number 9. Okay, so it says, find the future value and the interest earned if 8704.56 is invested for 8 years at 5% compounded semi-annually. Okay, so y'all, in the notes for 4.2, there is a compound interest formula. So I'm going to give you the formula right here. Oops. And then I'll explain to you how the formula works. Okay, so this formula here, y'all, I like this formula. Why? Because it's about money. And hey, you know what? We all need a little bit of money every day, right? We all got to have some money. Okay, P stands for the principal. That's the money that we're investing in our account. Okay, so let's see. How much money are we investing? $8,704.56. Okay, and then 1 plus R. R is my interest rate. So y'all, if my interest rate is 5%, we need to write it as a decimal. As a decimal, it's 0.05. Okay, so right here, y'all, I'm going to put 0.05. Now, the next part of the formula has the letter N. N stands for how many times is my money going to get compounded in a year? And look what it's telling me, semi-annually. Semi-annually means every half of a year or every 6 months. So that means that they're going to compound my money at the end of June, and then they're going to compound my money at the end of December. That means it's going to happen twice. If it's semi, it's going to happen 2 times. So my N is going to be 2, okay? And then raised to the power N times T. So we just said our N was 2, and look at my time. My time is, guys, it's always going to be in years, okay? So our time in years is going to be 8. Now that I wrote it out like that, the next part, y'all, I'm going to do this on my calculator, and I'm going to show you how I'm going to do this on my calculator. I'm going to enter this in exactly like the way I have it written here, okay? There's no question on how I'm going to do this because I'm going to enter exactly what I have. So look, let me clear my screen. So I'm going to type in 8704.56. And then I know I didn't write it here, y'all, but I'm going to put it here for us now. It means multiply, okay? So I'm going to put times, and just like the way I have on my paper, I have a parenthesis. So I'm going to put a parenthesis. 1 plus 0.05 divided by 2, because that's what I have. I'm going to close my parentheses, and then I'm going to raise this to the power. Look at my power. My power is 2 times 8. What's 2 times 8 anyway? 2 times 8? 16, right? So look, my power is, oops, I need to put the power button. I didn't put it. That's my power button right there, y'all. The little up arrow, the one right above the division sign. 16, I'm going to hit enter. And the number that I'm coming up with is 12,921.90. I'm going to go to 2 pennies, y'all, because it's dealing with money. So 1291.97. So 12,921.97. Okay. All right. Now let me show you something. I'm going to come back to the problem right here, and I'm going to enter that in. 12,921.97. I'm going to check it. Hey, we got it. Okay, look at the next part. The next part says interest earned. How much interest did we earn? So let me show you what I mean by that. Remember how much money we had? We had $8,704.56, and we ended up with $12,921.97. How much money we earned would be my interest. So if I want to find my interest, I'm going to take $1291.21 and I'm going to subtract 8704.56 cents. So let's do that. 12,921.97 minus 8704.56, and I'm coming up with 42.17 and 41 cents. So 42.17 and 41 cents. So right here I'm going to put 42.17 and 41 cents. Oops, I was writing in 42.17 and 41 cents. And I'm going to check it. Hey, we got that part right. Okay, now there's a part B. Part B says, what happens when we compound this continuously? So let me show you how I'm going to do part B. Part B says continuously. There is another formula for that, y'all. This is the formula, the continuous interest formula, y'all. Some people call it the PERT formula because it looks like it spells the word PERT. But it's the same kind of formula. And the difference is remember in the first problem we said, because, and I'm going to zoom in a little bit, those watching from here, from home. Remember we said semi-annually meant? It means that our money was being compounded twice a year, every 6 months, right? Every half of a year. Continuously means the money is being, your interest is being compounded all the time. There's never a time that your interest is not accumulating, okay? And so the way I'm going to do this, the same way. The number here we had was 04.56. Now, this number E, y'all, this is a number on my calculator. So I'm going to leave that E alone. Our interest rate, remember our interest rate earlier was 5%, which we said as a decimal was 0.05. So 0.05. And I want to say that our time was 8 years. So times 8, okay? And this is exactly how I'm going to type it in on my calculator, y'all. So look, I'm going to get my calculator right here. I'm going to write 8704.56. Now, see how we have that E there? On the calculator, the way you're going to get to the E, you're going to hit the second button. And right here, right next to the number 4, we have a button that says LN. If you look right above it, there's a little E. So when I click on that, look, there's my E. You see it, E? Okay, now look what my power was. It was 0.05 times 8. So I'm going to put 0.05 times 8, close off my parentheses for my exponent, right? So I'm entering this in on my calculator, y'all, exactly like the way I'm writing it down on my paper. And when I hit enter, look what I'm coming up with now, 12,985.68. 12,985.68. What I want to point out, y'all, this was the amount of money we got the first time when they compounded it twice a year. This is the amount when the money was always being compounded, when the interest was always accruing. It was more money, right? Not a whole lot more, but it was more money, right? So 12,985.68. So right here, y'all, I'm going to enter 12,985.68. I'm going to check it. There we go. And then the last part says, how much interest did we earn? So remember how we find our interest? We're going to take this number here, and we're going to subtract that number there, okay? So again, let me go ahead and do that on my calculator. So let me minus 8704.56. And I'm coming up with 4281.12. 4281.12. Oops. 4281.12, because I am rounding to the nearest penny, and we got it, okay? So again, all I'm doing, y'all, is I'm just using the formulas, and again, the way I write it down on my paper is exactly the same way I'm going to write it in on my calculator, y'all, or using the calculator app, it's going to work exactly the same way, okay? All right, so y'all, just friendly reminder, homework for up to 4.3 is due by Thursday, okay? And then y'all, I'm going to put one more thing up. I know those of you who are at home are still, maybe you're still here, I don't know. But I'm going to share one thing so that you guys can see here. Let me go like this. Where's my weekly activities folder? There it is. Okay, so look, y'all, right here under the weekly activities folder. So right now we're in week 11, and then we got week 12. So week 12 talks about our review for test 2 and our test 2 days. So test 2, y'all, covers chapters 3 and 4, okay? So for this coming week, this week that we're going on, right? Remember, I extended those deadlines just to kind of give you some extra time. But this week right now that we're in, y'all are supposed to be doing 4.4, 4.5. And then next week it's 4.6. So y'all, on Thursday, November the 18th, I'm sorry, that's when everything is due. So let me see, what day are we going to do a review? I wrote it somewhere on here. Here we go. Where did I put it? Here we go. On Tuesday, November the 16th. So that's 2 weeks from the night, y'all, is the night that we're going to use to review for the test. Okay, so let me pull up the calendar. So 2 weeks from the night is when we're going to review for the test. And then I'm going to open up the test that night. So that night, y'all, the test will be open, and you'll be able to take it anytime between the 16th and November the 24th. I want to say, here it is. So look, November the 16th through the 24th, right? And so let me come back to my calendar again so you can see. So the test will be open, and this is the week, so it'll be open the week before Thanksgiving and the week of Thanksgiving up until that day before Thanksgiving, okay? So y'all, if you're gonna be doing Thanksgiving and you gotta do a whole bunch of prep on Wednesday, don't wait till Wednesday to take your test. You know what I mean? I don't want you like, oh my God, I'm trying to make stuffing and I still gotta take my test, right? Take the test beforehand. The week before, that 16th, the week before Thanksgiving, that's the night that we're going to use to review, okay? So once you finish the stuff for this week, which is up to 4.3, then you really have 3 sections to do. It's 4.4, 4.5, 4.6, okay? There's also a quiz there, and then there's a review. So what I would do, y'all, whether you're watching from home, y'all, and I don't know how many people are still watching from home. Oh, everybody's still here. Let me stop sharing this real quick. Well, I'll come back to this part. Whether you're watching from home or those of you who are here, the review is already open. Start doing a little bit of it. You know what I mean? Like, you don't have to do all of it in one sitting, but like once you finish one of your homeworks, see if you can do 5 problems in the review. And then once you finish the next homework, see if you can do another 5. Just do it like in pieces like that, right? We got basically 2 weeks from today so that I can answer those questions in the review. Now the review, y'all, is going to be open all the way until the 24th. Okay, so that day that I review, the review is going to stay open until the following Wednesday so that you can keep working and stuff. But look, the review has 42 questions. So if you do 5 problems here and there, you'll knock it out in a week. You know what I mean? And like I said, y'all, Tuesday, November 16th, not next Tuesday, but the Tuesday after that. So I'll remind you again, you know, and I'll send you all an email and I'll send you guys something on as well. But just wanted to kind of give you a heads up, okay? And I did include a formula sheet right here, y'all. So if you click on this here, there is a formula sheet for test 2, and it's got everything that you would possibly need for the test, okay? So again, just wanted to give you a heads up, okay? It'll be the week before Thanksgiving, and it'll be up to the day before Thanksgiving too, okay? So you have a whole week to get the test done. So you got a lot of time. 3 and 4, yeah, the test covers 3 and 4. And then after that, y'all, we're pretty much done. We got 2 sections left after chapter 4. We just have 2 sections left. Remember earlier in the semester, we had an assignment that you all had to do on paper, and then you had to send it in. We're going to have one more like that week after Thanksgiving. And the week after Thanksgiving, y'all, what we're going to be doing is reviewing for the final. And then the final will be the week after that. So we're almost at the end, okay? So really, y'all, after you finish the stuff for chapter 4, or up the stuff that's due this Thursday, you really have 4.4, 4.5, 4.6, and then 5.1 and 5.3, and that's it. So after this Thursday, there's really only 5 sections of homework that y'all got to do. There's one written assignment in there too, and I'll send you all the info about that, and I'll put that up on Blackboard as well. But we're almost coming to the end, y'all. Okay, so just hang in there. We're almost done, and then we have a month off for the winter break. Okay, so think about it that way. I know it's kind of hard and it's been a little tough, but you know the good thing is we get to see each other the one day out of the week, and we get to do it like this. Okay. All right. So now let me stop recording and